Okay, hello. So it's time. Let me get started. This is a weekly Houdini tutorial live streaming that I'm doing recently. And today's topic is to create a line drawing based on an input image like this, and together with a bit of small animations like this. こんにちは、こんばんは。And be able to procedurally change the resolutions by changing some parameters. Like here. Maybe flip the brightness like this. Maybe it's a bit hard to see the changes here. So yeah, let me get started with this one. And I am going to create it from scratch and explaining how I can achieve this thing. First of all, I need to have an images in order to create this line drawing. So I have downloaded some images from this website called Pexels, where you can download free images. And you better have some image with a strong contrast, because you're gonna make it black and white later on. So I choose something like these. Alright. Okay, let me quit this one. Okay, so let's get going. The file that I have created, you can download it from the link in the description, video description. So you can download it to actually use it while you watch this live, so that you might understand better, I guess. So if you want to do that, please do that. Okay, so let's get started. Now, first thing I would like to do is to create a new node where I have all the parameters that I want to control. Oops, not here. First of all, make a geometry node, right? And then create a null node. And I am going to name this controller first. Better change the text to English. Yeah, controller. Okay, it's a bit slow here. Right. And in a controller, I am going to create some parameters first, so that I can use it, control it later on. First of all, I would like to add a file path for the image. So I'm gonna choose this file image, bring it here, and name this, say, image. All right. And also some integer value to use it for image resolution. I am going to name this image size, and let's set the range from 0 to 100. I don't need to make it too big, since if you make it too big, it's gonna be really heavy. So I'm gonna restrict to 100 as a maximum for now. And in order to control the flipping pattern, flipping of the diagonal lines, so in some part I want to flip the diagonal line which goes from left bottom to a bottom right to right bottom to the left top diagonal line. So in order to change that, I am going to create some boundary geometry like a sphere or metaball on top of the image. Where the image is covered by those spheres, I want to flip the diagonal lines 180 degrees. So in order to create a sphere, I'm going to set a number of spheres or metaballs, saying pdnum indicates the number of balls. And let's also create a float parameter called ball size to determine each ball size. And I would like to move those balls as an animation which might bounce inside the image boundary, so that it will be more procedurally interesting, more Houdini-like. So let's also do that by setting a speed for a ball animation. I'll say ball speed. And the range, I'm not sure, maybe 0 to 0.1 might be good. Right, and last of all, I'm going to make two additional flow parameters in order to control the thickness, the minimum thickness and the maximum thickness of the line based on the contrast of the image underneath. So I'm gonna name this min scale and the max scale. So if the color value or the brightness of the image is brighter, meaning it's close to white, then use the maximum scale. And then if the brightness of the color is low, meaning if it's dark, then use this min scale in order to control the thickness of the line. Right, so that will be the all parameter that I'm gonna use. I'm going to set some range for minimum maximum scale to 0 to 1. Other than that, ball size, let's set it to from 0 to 1. Okay, other than that, it should be okay. Now I apply and accept. Now let's set some random values for all the flow values in integers for now. Maybe something a bit low, like this. Right, now, first of all, let's click this button right on the image path and choose the image that I'm going to use for testing. So I'm going to use this skull image for now. Alright, now before getting into a detail how I am going to do this using Houdini, let me just explain a basic flow what I'm gonna do here. And by explaining this, some might understand how to do that before seeing my detailed process, maybe in your own way. Right, so first of all, I'm going to import some image, and then what I'm gonna do is to create a diagonal line on top of this image. And from the grid, so first of all, I have those grid plane, and for each grid, I am going to create this diagonal line for each squares on top of the grid, like this. And for each grid on the center point, you want to sample the color value underneath this image. So if you're looking at this point, and meaning you want to sample the point at this location of this image, then get the color, get the brightness, and feed into this each diagonal line, which is created as a single line, and do this for all the lines existed in this plane. And after that, I'm going to bring some spheres or metaballs like this on top of the image to cover up the image, and flip the diagonal lines which is inside this ball. So you want to do something like this. By preserving the color attribute or brightness attribute for each lines. And after that, I'm going to set the thickness for each line based on the color value, the brightness value that it has. So at the end, the line thickness, well, it's a bit hard to you want to control those line thickness to make it look like a flower, but it doesn't really look like a flower. Well, let's just say like ambiguously like this, by changing the thickness based on the brightness for each lines. So let's say brightness is equal to 0, then you want to make it thing. If the brightness is equal to 1, then you want to make the thickness thicker. So this is the process that I'm gonna follow, and it's not going to be that hard, I think. Rather easy compared to other things that I do. So let's do this. First of all, I want to import the image. So to do that, I'm going to use a cop2 network, since it's going to be much easier to control the scale or the size compared to using attribute map attribute node. So I'm going to use this one. So after making this cop2 network, I'm going to double click in it, and then first use a file node here, and then connect with a scale node in order to control the scale, because you don't want to just use the raw resolution, because it's going to be really high in my case, because the image that I'm going to import has like a 4K resolutions, which is too big to use it precisely. So I'm gonna reduce to the size that I have set in the parameter. Which is this one, image size. So this will be the maximum size, either a width or a height. So 30 might be too low, but 50 or 60 is pretty much enough for this kind of line graphics. So let's copy this parameter and go back to the cop2 network and go into the scale, and I'm going to set some expression in order to change the scale of this image based on the parameter that I have as the size. And to do this, I'm going to change the scale mode to fraction. Yeah, fraction is fine. Right now it's 1 to 1, but what I want to do is to first paste the parameter that I have created, which is image size, and this will make 45, but which means you want to make this image 45 times bigger, but that's not the case. What I want to do now is to copy the size here from this file node, this one, and let's also change this name here to something like image, and copy this size, the x value of this size parameter, and then divide this image fraction, first image fraction value with the value that I have copied, which makes this scale and makes this size to be 45, which I have set it here, right? And I'm going to do the same thing for this one, the second value. So basically what I would like to just copy this into here, but the problem is that I want to set the fraction, image fraction, to be the same for the left and right, and I have to choose either the x value or y value of this image in order to create the same fraction value. But right now, well, this image is square image, so that's fine, but if the aspect ratio is different, then I have to choose either the x value or x size, the width or the height, in order to set the same fraction value. So to do that, I'm going to set another expression here saying just choose the maximum of width or height. So choose either height or width, which is larger. In this case, size 2, like this. And I think I'm missing some expressions here. So I have this one. Let's just copy this and paste this here. Say set it to 2, right? Now it says, I guess it's the same value, but I am going to copy this again and paste it here. Now it's hard to see the difference because this is a square image, so let's change this image that I'm gonna import into the one that I want to use, which is this one. So let's copy this parameter from the node controller and go back to the cop2 network and paste the parameter here and the file parameter channel, like this. Now the skull has been imported, and even though the aspect ratio is different, the width is a bit smaller than the height, the image fraction is calculated correctly and made the image size, so the width became 32 and the height became 45. So always if you use this method, you get 45 to be the maximum size of the final scaled image, and the 45 came from here, this parameter. So this is how you can procedurally control the image size. So whenever you change the image, you can still control the maximum size of the image. So I think that's one good tip to control the image. Okay, now that I have a image imported like this, I want to just change it to the black and white or grayscale image. So I'm going to use a node called mono. I guess means monochrome. and then make it grayscale image like this. Now it looks like it looked really low res image, but if you just change it to a line drawings, and you'll get much better result. So don't need to care about much about it. Right, so let's go back and display this image, and you'll get this grid image with a color parameter, color attributes for each point. If you look at the geometry spreadsheet, like this, and the X and Y and Z value for the color is all the same because this is monochrome image, a grayscale image, so I'm just going to use one of those value in order to sample the color value, brightness color. Right, since this plane is right now in XY plane, I would like to set it to XZ plane instead by set this plane to ZX. Now let's also, I want to set the width direction to be the X direction. So right now the width direction is Z direction, so I'm going to use a transform node to rotate 90 degrees using Y axis. The reason why I want to do this is because if I change the view from perspective to top, then the view, the image is flipped 90 degrees like this, so that doesn't look good. So let's rotate this 90 degrees in positive direction like this. Right. Now that was the importing part of the image. Now if you look at this image, if you look at this image, if you look at the information of this image, it says you have 1440 points, but you only have one primitive. So this is a one mesh primitive, which is a bit hard to use when you want to create a line for each grid cells. So I would like to convert this mesh into a polygon by using convert node, which explode this mesh into a tons of polygons, consist each squares to be separate primitive. Right, and after that, let me also attach a normal node for a surface for primitive, which I'm gonna use it later on. Well, basically you don't really need those because all the plane is facing upward, but just in case. So the primitive normal is facing upward like this. You might not need to have this though. It's just a precaution. Okay, now everything is set for preparation. First thing I would like to do is to sample a color value for each primitive, or each point, I guess. The point is better, I guess. So for each point on a grid, creating a grid, I would like to create a final say scale value for the lines, which is controlled by this max scale and the minimum scale by converting the brightness value, which is right now in a CD parameter or CD attribute. Hello. Okay, to do that, it's pretty simple. I'm gonna just use a point wrangle node. Point wrangle node. And I'm going to name the attribute p scale because it's broadly used in Houdini. And what I want to do is to convert the color value, either X, Y, or Z, into a p-scale value in order to control the thickness of the line. So the p-scale is equal to fit color at cd.x, could be Y or Z as well, which is from 0 to 1, and change the value into a range of minimum and maximum value that you have set manually as a parameter here. So by using CHF, you can click this button to promote the parameters that you have named here, minimum, maximum. So this is where you want to link the parameter that you have created here inside the node controller. So copy this parameter, paste it here and here as well. Let's rename this to max. Okay, and click the label to see if the value has been linked correctly. And I think it did. Looks good. Now this is all for promoting the p-scale, and I'm going to use it later on. Now next thing I would like to do is to create a, let's say, a boundary, maybe some balls or metaballs, in order to cover the image, in order to use it for flipping the diagonal lines. So let's do that. I'm going to do that by first creating a bounding box of this image. And then since this is a flat image, I'm going to set the bounding box to be rectangle, like this. Right, and now let's create a random scatter point by using scatter, which will be the initial Metaball position. And the number of points are too much right now, so let's control that by using the parameter that I have created, which is called pdnum. So copy this parameter, paste it to the false total count here. Right, so now I should have 6 points on top of this boundary plane. Right, like this. Okay, now the thing that I want to do next is to move those points inside this bounding box, bounding rectangle, initially at random direction, then bounce it based on when it hit the edge of the bound. So to do that, I'm just going to set the initial velocity direction where the points want to move. So I might could do that by attribute created, but I am going to use point wrangle again to do that, and name this random velocity, and create an attribute called vel, meaning velocity, and create a random vector for x, changing the x value, and z value. Since this is on the xz plane, I don't need to change the y value. This, and let's also normalize this so that the length of this vector will be 1. Okay, that should be enough for the initial direction. Right now I'm not using a speed value yet in order to move this point. I'm going to do this by creating a subsolver and use the speed inside this one. So for the first input of the subsolver, I'm going to input this point image, point with the velocity information. And then for the second input, I'm going to input this boundary to use it as a guide to bounce the ball, bounce the point, right? Okay, double click to get inside, and first thing I need, this is just going to be really simple calculation, simple bouncing calculations. And to do that, I'm going to just use one point wrangle. So this one is the previous framed point coming from the previous frame. So connect that to the first input of the point wrangle. Let's name this bouncing. And for the boundary box, which comes from the input 2, I think, yeah, to the second input of this point wrangle. I have the comment saying, excuse me, did you type this live? I'm not sure what you mean. Did I type? How did I type? I'm not sure. Okay, let's go back. So in the point wrangle, I'm going to set a speed of the balls, and if the ball goes outside the boundary, then go set the position to be inside the boundary, and then choose change the direction of the velocity. And that's the whole thing that I want to do inside this bouncing function. So let's do that by opening this scripting editor. First thing I would like to get is the minimum position of the bounding box. So in this case, negative x and z value, which is here, which is on the left top corner, and the maximum x and z value, which is on the right bottom corner in this case. Right. So vector min. You can get that by using a function called get b box min from the second input. For the maximum value, for the maximum point position, get b box max 1. Right. And also let's get a speed value from the parameter by creating a channel so that you can link with the parameter that you have created inside a null controller. Okay, apply and click this button so that the channel will be promoted for speed. Now let's go back to the geometry node, copy the ball speed parameter here, and then go back, then paste it here. Right. Now let's check. Okay, the link has been correctly done. Okay, now first of all, I want to move the point position using the velocity, and by multiplying the speed, you can control how much you want to move the point for each frame. So the velocity value is, the size of the velocity is always 1, so by multiplying with speed you can control the speed for the frame, for each frame, how much the ball should move, the point should move, right? Okay, now's the part that you have to apply in order to bounce inside this boundary. So that is done by creating some conditions. If a x coordinate of the point is less than minimum x, meaning if the point goes outside, goes to the left side, goes to somewhere around here, then first of all, move the x coordinate of this point back to a minimum x plus a bit of margin, so around here probably, and then change the velocity x, the x value of the velocity, by multiplying by -1, so that last time the ball was going this way, but if the ball goes outside, then you want to change the ball direction to go from left to right, if the ball was going from right to left, which creates the bouncing effect, bouncing movement. Now do the same for all the x maximum value, z minimum value, and z maximum value. So I'm gonna copy this 3 times more and change those to z for the minimum, and for the maximum I'm going to change this operator so that if the pz, or let's say px, is greater than max x, then set the point position to be max x minus 0.001, and for the velocity for the x, do the same thing, just multiply by -1 so that the direction will be flipped. And let's also copy this one and paste it here and rename this x to z. And that's all you need to do. Now let's test out by setting the flag to this bouncing node, the point wrangle, and then go back to the geometry node and play while showing the boundary and see if the ball bounces. And yeah, it seems like it does what I want. So that looks good. Now it's just a ball right now, so it's just a point right now. So let's convert it into a sphere or metaball. And in this case, I'm going to use a Metaball because it will create a more organic connection of the balls, which is a bit more prettier in my case. So create a Metaball like this, and from the parameter on the null controller, copy this ball size, copy parameter, and go back to the Metaball and change the radius with this parameter that you have set for x, y, and z. Okay, now use copy to points node to copy each Metaball into this point that have been moved by the solver. Then play it, and you can see some interesting animation already. Right now, this Metaball is not a polygon, so you cannot use this for analysis later on. So let's convert it into polygon in order to check if the diagonal line is inside this Metaball or not. So to do that, I'm just going to use the convert node, right? And that is too low res. I want to change a U and V value here. So let's set it to something like 2, maybe 1. 1 might be enough, because you don't need to make it too like high res for this one. It's just the boundary information. So make it low res is not. It's fine, just fine. And I think this is just fine. Right. If you have a high spec PC, then it's fine to make it high res like this. But for myself, I'm gonna set it to 1. Alright. Now's the time to create a diagonal lines and flip the line based on the position of the metaballs and on top of these boundary box. Right. To do that, I'm going to use another point wrangle again. Okay, so connect this Metaball into the second input of this point wrangle, then connect the value and that have p scale for each point to be on this first input of this for this point wrangle. Right. Now let's do this. Let's create the diagonal lines using this one. Oops. And let's name this diagonal lines. Right. Okay, the first thing I would like to get is the number of grid, which corresponds to a size of this image, which this one, maybe, or maybe not. Maybe not. Let's skip that. Okay, the first thing I would like to do is to okay, I might made a mistake. So this shouldn't be a point wrangle. This should be a primitive wrangle, because I want to create a line for each primitive, which is for each grid cells. So I'm going to look through all the cells, and for each cells I want to create the lines either in this direction or in this direction, based on the position of the Metaball. So if the Metaball, like this one, is covering the cells, then I want to flip the direction of the lines. If not, then just create a line in this way. So I should change the run over to primitive instead of points. Okay. And for each primitive, I want to get the list of points, which creates each primitive cells, grid cells, by using prim points function. Okay, and I'm going to create an empty variable called ptnum1, ptnum2, which will contain the number of points, the index of the points to connect the lines. So either this point number and this point number, or this point number and this point number. So the point number will change based on the condition, whether it is inside a Metaball or not. Right. And in order to see whether the point is inside the Metaball or the primitive is inside a Metaball or not, I'm going to use a function called intersect. So to do that, I need to create some empty parameter like intersected point, intersected u and v, and use intersect for second input, which is the Metaball polygon, and from the point, from the add P, which is going to be the center point of each grid cell, look upward 0, and make it really big value so that it will penetrate the it will intersect with the polygon, the Metaball polygon. Then apply attach P, U, and V, which I'm not going to use for this, but need to add it in order to use this intersect function. So if the result of this intersect is negative value, which means it didn't have any intersection. If it's positive, greater than 0, then it means it has found the intersection. So I'm going to create a condition saying if enter is negative, meaning if it couldn't find any intersection, then set the ptnum1 to 0 and ptnum2 to 2. Else, so this means that in this case, the point value here, the point number here should be 0, 1, 2, 0, 1, 2, 3, I think, counterclockwise. So I'm choosing the value which diagonally connecting in this way, so which is 0 and 2. So if the intersection is positive, meaning if it touches and if it penetrates with the Metaball, when you have the ray upward, then you want to change this ptnum1 and ptnum2 to 1 and 3. So ptnum1 equals to 1 and ptnum2 equals to 3. Right? And this value is used to get the real point number from this value. So the actual PT number is achieved by like this one, by writing like this. Okay, so let's try to create a line connection between those 2 points by using a add prim polyline pt1 and pt2, and remove the original grid cell, which is this square, because I am not going to need this anymore. Like this. Okay, and looks like it worked, I think. And it's a bit hard to see because the color is also being transferred together with the primitive. So let's attach this attribute delete before this diagonal lines primitive wrangle, and for the point attribute, let's delete cd. And I think, but in order to create a diagonal line, it worked well, I think. And the line is flipping based on this Metaball position, I think. Yeah. and it is smoothly connecting with other lines like this, so looks good. Yeah, looks good. And if I play the animations, the line should also change. So that is also good. All right. Now, the last part is to set the thickness for each line based on the p-scale value that have been converted from the color brightness, which is this one. So use this p-scale in order to add a thickness for each line, and that will be the final step. Okay, now I'm going to do a bit of coding here again, but before that I wanted to use this poly expand node. This is pretty useful. If you set the output to something like offset surface and set the offset value to really low value. Wait, maybe too low. Okay, I cannot see the changes. Let me also set the color to black. Now, if the thickness of the line is constant, then the polyexpand node works pretty well like this. And I thought that I could also use p-scale value in order to control the thickness for each point by checking this inside scale and outside scale. And if I change it to p-scale and p-scale, then I thought this will work well. But somehow it didn't, like you see here. You don't really see the image which should look like this skull image, but doesn't really look like so. I don't know the reason why. Maybe it's some restriction with polyexpand 2D, because if I don't use the diagonal lines, if I use instead this grid lines, it seems to work well. But once I change it to diagonal lines, it just doesn't work. So I don't know why it's that. So I wanted to use that. If I could use this will be really easy one, but since I cannot use this method, just changing the p-scale and p-scale, I'm going to do it by using a script. And sorry for that. Okay, so in order to do it by a scripting, I am still going to use this polyexpand 2D, but with the constant value like this. First thing I would like to do is to first create a thickness line for each diagonal lines here with this polyexpand 2D as much as possible, as thick as possible. So without much space here. I had a comment saying if you make it unique points. I have also tried making all the points unique, but yeah, it still didn't work. I'm not sure why. Yeah, I'm probably think it's because this is connected as a continuous line. Maybe that's the reason. I'm not sure. Or you need more than 2 connections for each lines, because for squares it has 4 connections for each point. not sure. Yeah. So what I'm gonna do is to first set the thickness for this polyexpand 2D in order to have a small gap as possible. And later on, use the script to scale inward to scale those thickness of this strip using the p-scale value. Right. So to do that, I need to know how much scale, how much thickness I need to set for each strip, and for that I can calculate from this image size is image resolutions. So the first I can calculate the grid cell size, which is this one. The grid cell size can be calculated by, well, since the maximum size of this image imported from the COP2 network is 1, so in this case the height is larger than the width, so the height is 1 in this case. And the height, for the height value, you have 45 grid cells, and you have defined with this parameter value. So in order to calculate the height or width of each grid size, you can just divide 1 by this 45. So, and for the diagonal lines, you need to have this diagonal direction, not the width or height, but diagonal direction. But you can also calculate that from the width or height. You just have to divide this width, or you just have to multiply this width or height by square root 2, I think. Yeah. Yeah, I think that's it. Yeah. So keep that in mind. Let's calculate that. Going back to the polyexpand 2D and create some expression for this offset value. Okay. Right, so first of all, 1 divided by image size and multiply or divide it by 2, since the offset size is only for the half size of the offset, and then divide it by square root 2, which looks still big, maybe. And what if I multiply this by 0.99? Nope. Maybe something is too big here. 1.0. Looks small enough. Let's go back and remove those, and wait, let's cut this, delete this channel and see it manually before get it into the real value here. Obviously this is not good, so let's see if I make it smaller. Wait, is this the smallest size? Okay, maybe I have set, I need to reset this value for coincide tolerance. Doesn't look good. Let me delete this and do again. I might have changed some values. Right, let's do this. Sorry for that. Change this to offset surface, and Okay, I have a comment saying you always add 0.0 at the end. Is it better than just put an integer since everything else is float? Yeah, if everything else is float, I guess you don't need to set 0.0, but it's just my habitat, or just to make sure I don't make mistakes. In some case, if all the value is integers, you'll get the integer value as a result. So I guess it's just my way to make it sure that everything is float. But if anything else, if the value that you're calculating with is float, then I think you can just use integers. But it's really depend on the platform. In Vex, it might work like that. In other language, it might not. So just doing that way so that it will work in every language and every platform. Okay, so the offset, do the same expression, 1.0 divided by the size of the image, multiply by 0.5 divided by square root 2. Yeah, that should work. And now the size is a bit strict. It's really touching and without any gaps here. So in order to add some gaps, I think I need to have a little bit of gaps in order to control the thickness of, because if it's touching, then sometimes the primitive is made, some of the point has been fused or merged. So that's not what I want. So to make it everything independent, let's make a gap by creating this value a little bit smaller, like multiplying by 0.99 or something. Then I will have some gap in between those strips. Yeah, that's good. That's good. Now the final step that I want to do is to scale each strip for at each point with the p-scale value. So if the p-scale value is small, then scale this strip smaller. And if the p-scale is close to 1, then keep the strip size as this. As this. Look. Alright. To do that, I need to apply some additional attribute for each point, for each strip endpoints. So if I am looking at this strip, first of all, you have started from this point. You have this point here. And if you have if you have used the polyexpand 2D to create a strip, you will have additional 2 points for each point. So for this point, you'll get this point and this point. And you want to find out which point, if you look at it, this point, you want to know the center point, the original point, original diagonal line point for each point that you're looking at. So if you're looking at this point, then you want to know that this point is related to this point. If you're looking at this point, then you want to know that this point is related to this point. If this one, then this one. If this one and this one, like that. So that you'll have the information that which direction should this point go in order to scale down or up. In this case, if you want to scale down, then you want to move this point to the center point direction. So you want to move this point left side like this. For this one, you want to go upside like this to this original point position. To do that, you need to have all the pairs for those 3 points to have same attribute like IDs. So I will attach an ID before creating a strip. So in between the polyexpand 2D and diagonal lines, I'm going to create a point wrangle saying ID, and I'm going to attach a ID attribute using a ptnum for each line, each point number which creates those lines. So which is corresponds to the point number of this diagonal lines. Okay. And after I have created a polyexpand 2D, and if I look at the geometry spreadsheet, I should have 3 IDs for whole points. The three pairs of points having same IDs like this, as I assumed. Yeah. Now that I have those information, and if you look at the p-scale is also preserved, and that is also good. Right. Now the only information I need as an additional information is whether, so I have 3 points here, right? And I need to know which point is on the side of the strip and which point is on the center of the strip from these 3 points. And right now, if I look from this attribute, I don't see any information to determine that. So to get that information, I need to promote some attribute from this polyexpand 2D, which is this edge distance attribute. This is to determine, this is to add an attribute for a vertex, for each vertex, how much point have been moved from the center, from the original line position. So if you go back to the attribute again, nothing has been added to the point attribute, but if you look at the vertex, then you see an additional attribute called edge distance, like this. So 0 means it didn't move, which means it's on the center, which is on the original diagonal lines from these points. The value, if the edge distance is greater than 0, then which means the point has been moved, so these points are on the edge of the strip. So by using this information, you can guess which point is on the edge or not from those pairs of points from those 3 points. Okay, keep that in mind and create some script to determine which is center and which is on the edge, and move the edge points, the strip edge point, toward the center based on the p-scale, and that's the final thing you want to do. Right, scale, strip scale. Okay, this is going to be the final step, and it's going to be a little bit of coding, but don't worry, it's not that long. Okay, first thing I would like to first thing I would like to do is to get the okay, for each point, so I'm using the point wrangle right now, right? And for each point, I want to find out the set of points which shares the same IDs. So if you're looking at this point, then, and if the ID is 0, then you want to find the other 2 points which have same ID 0, which is this one and this one. So what I want to do is int pts array find attribute attriv val from the point attribute. The attribute name is ID, and find with your own ID. So for each point you have your own ID, and you want to find all the point numbers which shares the same ID, like this. So in theory you should get 3 point numbers by using this function, including one of the point which is equal to this, which is equal to your own number, your own PT num. Okay, now next you want to get the vertex value for your own point number. So use the point vertex with the PT num, and you want to get your own edge distance from this vertex number. Use from the vertex attribute, from the edge distance. Okay, so if the distance is 0, then you're looking at this point, meaning you don't need to move this point. If the edge distance is greater than 0, then you're looking at either this one or this one, which you want to move to a center direction. So let's make a condition. If the distance is greater than 0, then you want to calculate, first of all. Okay, now next thing you want to find out is this center point, not the other edge point, but center point, so that you can get the direction where you want to go, where you want to scale to. So to find out, I'm going to loop through all the points from the point that you have found using find attribute value, which in theory you should have total 3 points for each IDs. And pick the point number from PTS. And there is a case that this point number is exactly the same as PT num, so you want to ignore that. So if PT is not equal to PT num, you want to continue the calculation. Okay, now it's the time to get the vertex number for the other point number. So let's name this NVTX equal to point vertex for this PT1 number, and also get the edge distance value from this vertex. Like this. And if the n distance is equal to 1, equal to 0, which means is on the center, let's set it as this. I didn't do n distance equal to 0. I set it to n distance is smaller to a really small number, like 0.00001, is because sometimes, I mean, we're dealing with the computer graphics programs, and sometimes even if you thought it's 0, sometimes it's has some value, like really small values, like 0.0000 something. So make it sure that it's close to 0. I'm creating a condition like this instead of saying it's equal to 0. Okay. So if the end distance is less than really small value, then which means it's close to 0, then you want to get the point position of that point, which is this one in this case. So and pos equal 0.0 p pt. Well, if I'm doing like this, I should also use this value for this one as well. Probably. Yeah. And vector direction is the direction vector is the direction where you want to move this point. So if you're looking at this point, you want to go from here to the center point. So you can calculate that by and pos minus at p. And finally, multiply this value, this direction value with the p scale so that you can control how much it should move. If the p scale is 1, then the point will not point will move to this point, to the center point. If the p scale is 0, then the strip will be remained. The strip size will be remained. And finally, no, I was wrong. If the p scale is 1, it's nothing wrong. So that's how you create a direction. And finally, you want to add this direction to the original point position. Okay, and let's see if I'm having some errors here. Let's see where that is. Syntax error at 7 here, right? I was missing I. Okay, that should went well, and I am already seeing some skull. Now let's change the color to black. It's not changing the color, not sure why. Okay, and voila. By changing the thickness, I can see that I can see somehow a skull image by just changing the line thickness. And if I play it, well, it's a bit slow, but I'm seeing the graphics changing based on the Metaball position. Great. Now let's try to change some image and see if it still works with other parameters. Let's change the image to something else, like this eye. And yep, it still works. Now let's also set this view to top view. Okay, and change some parameters like image size. If you make it really low, you have some ambiguous line drawing, which is also interesting, but you don't know what that is really. If you make it high, you see more and more high-res photo underneath, but everything is drawn with lines, still lines like this. In my case, something like 40 is good enough. The point number, you can control the number of points. You can even set it to 0 if you want to just have the single diagonal direction. And you can just replace this Metaball with other like geometry like text if you have your custom boundary to change the diagonal direction. In my case, I'm using the Metaball, but it's up to you how you wanna change it. And you can also change the ball size here, speed. And by changing this maximum scale and minimum scale, but a P scale, you can control kind of a contrast of this image by changing the thickness of the line. Like if you set the scale for a minimum maximum the same, you just see like identical line thickness, which you don't really see anything, which you don't see really from anything from an image. If you flip the minimum maximum value, the value will be like flipped. You have some like negative value of the image, which is also interesting. Since this is parameterized, you can also animate this if you want. And if I play the animation, yeah, the bouncing ball is dancing beneath and changing the diagonal direction like this, but the overall image is kept, even if you change the direction of the diagonal lines. So that's it. That's how I made this kind of line drawings. The inspiration came from one of the image I found on the Pinterest. I am not sure the original author, but I wanted to create it like procedurally using Houdini, so this is how I tried. I hope you find something new here. I hope you find it interesting. You can download the file that I've created here. I mean, I have already uploaded the original file into the GitHub, and you can download it from the URL on the video description. Yeah, so please try to like modify it with your needs and try to create your own interesting graphics. Yeah, so that's it. If you don't have any questions, I would like to end here. Thank you very much. Thank you for all the comments. I'm sorry that my English is a bit like it's not my native language, so I don't speak well, but I'm doing my best. Thank you. Okay, so if no questions, then I would like to end here. One note, well, this stripping scale was kind of a invention for me. It was an interesting way to change the thickness of the strip for me to try out, so I hope you find it interesting as well. Okay, from Russia as well. Hello. Alright, then I think there's no question anymore. Let's end this, and I think I'll do another Houdini live next week at the same time as well. If you could join, I'll be glad to have you all. Okay, thank you, and see you next time.